In 1977, something happened that scientists still talk about today. A strange radio signal was picked up by a telescope in Ohio. It was so powerful, so precise, and so mysterious that one astronomer simply wrote the word "wow" on the data sheet. And that's how it became known as the wow signal. For nearly 50 years, researchers have tried to explain it, but every time they think they have the answer, the mystery gets deeper. Tonight, we'll walk through the story of the wow signal step by step and explore what might really be behind it. Think about this. You are sitting in front of a huge radio telescope, a machine built to listen to the sky. The night is quiet, and your job is to check page after page of printed numbers, looking for anything unusual. Most nights, it's just boring noise from stars and galaxies. But on August 15th, 1977, something completely unexpected happened. That night, Ohio State University's Big Ear radio telescope caught a signal that didn't look random at all. It lasted exactly 72 seconds. That's a little over a minute, but it was long enough to change how scientists thought about life in the universe. The signal was so powerful, so neatly shaped, that it stood out immediately from the usual static. What made it even stranger was the frequency. It appeared at 1420 megahertz, what scientists call the hydrogen line. This is important because hydrogen is the most common element in the universe. Astronomers often say that if aliens ever tried to send a message, they would choose this frequency since it's like the universe's shared language. Everyone would know to listen there. The intensity was also shocking. Most cosmic signals are faint, barely whispering across space. But this one was shouting, like someone with a megaphone in a silent room. The signal even rose and fell in strength in a perfect curve as the Earth rotated and the telescope moved past it. That shape showed that the source was sitting still in space, not something moving in Earth's atmosphere orbit. When astronomer Jerry Ehrman checked the printout a few days later, his eyes caught a strange sequence of numbers and letters. In excitement, he circled it with a red pen and scribbled a single word next to it: wow. That small reaction gave the signal its legendary name. Scientists were stunned. This wasn't a random blip or machine error. It looked exactly like what people had been hoping for, a signal that might have come from an intelligent source far away. But just as suddenly as it appeared, it was gone. Later attempts to find it again turned up nothing. This raised endless questions. Was it a one-time message? Was it an accident from some unknown source? Or was it proof that we are not alone in the galaxy? For decades, the WOW signal stood as the best candidate for contact with something beyond Earth, and it remains one of astronomy's biggest mysteries. Picture yourself as Jerry Ehrman, the astronomer who found the strange signal. It's a normal day in the office. You're sitting at your desk with stacks of long computer printouts. Each page is filled with rows of numbers and letters, the kind of dull data you've trained your eyes to scan quickly. Most of it looks the same. Quiet. Repetitive. Nothing out of the ordinary. But then, you stop. Right there, in faded ink on a cheap sheet of paper, a sequence jumps out. 6EQUJ5. It shouldn't be there. The letters and numbers are the telescope's way of showing signal strength. Small numbers mean weak signals. Letters mean stronger ones. And this sequence climbs higher and higher, reaching the letter U, far stronger than almost anything recorded before. Ehrman stays at it. He's been doing this work for years and has never seen anything like it. The pattern is too neat, too perfect. It isn't random noise. It looks exactly like what they have been hoping to find. Without thinking, he grabs his red pen, circles the sequence, and writes one word in the margin. Wow. That one word made history. The WOW signal wasn't named by a committee or through some official process. It was the raw reaction of a scientist caught in the moment of discovery. In a field where language is usually cautious and formal, This burst of excitement felt human and real. News spread quickly among astronomers. For decades, researchers have been listening to the skies, waiting for something, anything, that looked like a message from beyond Earth. After years of silence, they suddenly had a signal that looked real. The excitement was electric. But as quickly as hope appeared, so did doubt. Where did the signal come from? Why was it heard only once? And could it ever be found again? What really puzzled scientists was the timing. The signal lasted exactly 72 seconds. No more, no less. That was suspiciously perfect. You see, the Big Ear telescope didn't move on its own. It stayed still while the Earth rotated beneath it, sweeping the sky like a giant scanner. Each point in the sky stayed in view for exactly 72 seconds. That meant the signal appeared for precisely the amount of time the telescope could observe that patch of sky. The shape of the signal was also a textbook match for what you'd expect from a stationary source in space. It rose, peaked, then faded in a smooth curve, almost like watching a lighthouse beam sweep across the ocean. Everything about it said, this was real. But how could something so perfect appear just once, then vanish forever? That question would haunt scientists for decades. Think about a radio dial. If you turn it slowly, you'll hear different stations, each broadcasting at its own frequency. Now imagine the same idea, but instead of music stations, you're tuning into the universe itself. Stars, galaxies, and gas clouds all make their own natural radio noise. Most of it is messy and spread across many frequencies. But there's one frequency that stands out from all the rest, 1420 megahertz. Astronomers call this the hydrogen line. Why? Because hydrogen, the most common element in the universe, naturally gives off faint radio waves at this exact spot. Since hydrogen makes up about 3/4 of all normal matter, this frequency is everywhere. It's like the heartbeat of the cosmos. Decades before the WOW signal was found, scientists had already guessed that if an advanced civilization wanted to send a message, this would be the perfect frequency to use. Back in 1959, two physicists even wrote a paper saying exactly that, if aliens ever call us, they'll call on the hydrogen line. It made sense. If you want someone to notice you, you don't whisper into static. You use the one frequency that every intelligent species would know about. So when the WOW signal appeared at exactly 1420 megahertz, scientists were stunned. This wasn't random. This wasn't chance. It was at the one place in the cosmic radio dial where everyone had been listening, the frequency often called the water hole. Why that name? Because hydrogen plus oxygen makes water, and water means life. For alien hunters, it was the ultimate clue. Even stranger, the signal wasn't spread across nearby frequencies like natural cosmic events usually are. It was narrow, laser-sharp, locked onto 1420 with precision. Natural sources are like boom boxes blasting static across a wide range. The WOW signal was like a finely tuned note, clear, focused, and impossible to ignore. Astronomers have been listening to that frequency for years without hearing anything unusual. Then, on one August night, the biggest, brightest, cleanest signal of all suddenly arrived. Like fishing in the same empty spot day after day, then pulling up a massive catch on one random cast. The coincidence felt almost too perfect. If you were looking for proof that someone out there was trying to say hello, this was exactly how you'd expect them to do it. But the universe loves mystery. The signal came once, then never again. No repeats, no second message, no long conversation. Just a single burst at the frequency of the universe, leaving behind more questions than answers. Consider this. You've just discovered the most mysterious signal in human history. It might be the first real clue that we're not alone. Naturally, you'd want to save every scrap of data connected to it. right? Unfortunately, that's not what happened. The Big E telescope collected mountains of data every night. Signals were printed on long sheets of paper, stored on magnetic tapes, and kept in boxes stacked in basements. For decades, researchers hoped to use that archive to understand the WOW signal better by looking at what came before it and after it, or by comparing it to other signals in the same part of the sky. But then came a heartbreaking mistake. In 1998, the Big E telescope was shut down for good. Budget cuts forced Ohio State University to close it, and the land was sold for development. The giant radio dish that once scanned the skies was torn apart. And much of the data it had collected, decades of careful observations, was either misplaced, dumped, or forgotten. The one surviving piece was Jerry Ehrman's famous printout with the red WOW scribble. Everything else seemed to vanish. That meant scientists had only those 72 seconds, frozen in time, with no way to see the bigger picture. Imagine finding a single page from a lost book, with no way of knowing what came before or after. That's what researchers were left with, a fragment of something that might have changed our understanding of the universe. For years, people searched. Some dug through university storage, others contacted former staff, hoping to recover lost tapes or papers. Most searches ended in disappointment. It looked as though the rest of the story had been erased forever. But then, a new character entered the scene, Robert Gray, an amateur astronomer. He wasn't a professional scientist, but he was obsessed with the WOW signal. And unlike most, he didn't give up. Gray began searching dusty basements, forgotten filing cabinets, and neglected storerooms. To his surprise, he found boxes of original printouts, tens of thousands of pages that no one had bothered to save properly. These weren't summaries. They were the raw records, filled with faint lines of numbers, almost lost to time. The paper was yellowing, the ink fading, but the information was still there. Gray realized he was holding a treasure, something the scientific world thought was gone forever. Now the challenge was clear. Could anyone rescue this fragile data before it literally crumbled into dust? Think about the patience it takes to copy a whole library by hand before it burns down. That's basically what Robert Gray decided to do. Between 2006 and 2017, he spent over a decade rescuing the Big E telescope's forgotten data. The old printouts were fragile, the ink fading badly. If no one acted, the information would disappear forever. So Gray brought in a simple camera and started photographing every single page. One by one, box by box. In the end, he had over 75,000 images, capturing more than a terabyte of raw data. It was slow, lonely work, but he knew what was at stake. Once the photographs were finished, the real challenge began, turning faint, aging printouts into usable numbers again. Regular text recognition software couldn't handle it. The computer fonts were too old, the ink too faded. The symbols looked like random marks to modern programs. That's when other researchers joined in. A team led by Antonio Perez created special software just for this job. They trained computers to read the quirky 1970s printouts, teaching them how to interpret columns, rows, and the unique code Big E used to record signal strength. The breakthrough was astonishing. Suddenly, decades of forgotten radio observations came alive again, and hidden in those dusty records were surprises. The WOW signal wasn't completely alone. Scattered throughout the data were other strange bursts, weaker but still unusual. Some had similar shapes, rising and falling in the neat curve you'd expect from a real cosmic source. For the first time, scientists realized that the WOW signal might not have been a single, isolated event. It could be part of a bigger pattern. The recovered records also gave something scientists had never had before: context. They could finally see what happened just before and after those famous 72 seconds in 1977. And the answer was crystal clear. Nothing. The skies were quiet. Then the signal blazed for just over a minute, and then silence again. That ruled out ideas about a slow build-up or lingering echo. Even more importantly, the restored numbers were sharper than the simplified versions that had been passed around for years. These details revealed that the WOW signal was actually more intense than scientists had first thought. Not just strong, but extraordinary. Robert Gray's Lonely Basement project had done something incredible. It gave the WOW signal new life, and with it came new puzzles, new questions, and fresh reasons to wonder what really happened that summer night in Ohio. Picture a giant pair of binoculars that can't move. That was the Big E telescope. Instead of swiveling like modern dishes, it sat fixed in place while the Earth's rotation carried different parts of the sky across its view. To do this, Big E used two separate antenna horns that looked at the same slice of sky, one right after the other, a few minutes apart. Now here's the problem. The WOW signal only appeared in one of those horns. That meant astronomers couldn't be sure which position in the sky it had really come from. It could have been the first horn zone or the second horn zone, two places separated by several arc minutes. For more than 40 years, scientists weren't exactly sure where to point their telescopes to follow it up. That uncertainty was a nightmare. Imagine trying to rediscover a lost city when your map might be wrong by hundreds of miles. Astronomers kept scanning the general region of Sagittarius where they thought the signal came from, but it was like searching in the dark with the wrong flashlight. The newly recovered data changed that. By carefully studying the complete sequence of observations, researchers finally had the timing information they needed to figure out which horn had really caught the signal. The math was conclusive. The WOW signal came from the second horn's position. That discovery shifted the source by 7.24 arc minutes from the spot everyone had been watching for decades. In human terms, that's a tiny distance on a star chart, but in astronomy, it's huge. It meant that nearly every follow-up search since 1977 had been staring at the wrong coordinates. And here's where it gets even more interesting. The corrected location wasn't some dull, empty patch of sky. It was a region buzzing with cosmic activity. Gas clouds, faint radio sources, and overlapping stellar systems all sit in that area. It's a much livelier neighborhood than astronomers had assumed. This new information ruled out some older theories. Earlier guesses that the signal came from a specific star or known radio source no longer fit. The new coordinates shifted the target away from those objects, eliminating explanations that had seemed convincing for years. But the best part, with a precise location in hand, modern telescopes could finally take a focused look. Instead of sweeping broadly, they could aim directly at the exact spot where something extraordinary had once shouted across the void. After decades of uncertainty, the WOW signal wasn't just a ghost in the data anymore. It had a home in the sky. Think about this. For decades, scientists thought they knew how strong the WOW signal was. The estimates range between 50 and 200 Janskis, the unit astronomers used to measure radio intensity. Even at those levels, the signal was already considered remarkable. But when researchers re-examined the data with modern methods, the truth came out. It wasn't just strong. It was off the charts. The updated measurement placed the signal at least 250 Janskis. That's more powerful than any previous calculation. And that jump in strength wasn't just a minor correction. It meant everything we thought we knew about the signal's origin had to be rethought. To understand why, let's compare. Our own sun, during quiet times, puts out about 1,000 Janskis at certain radio frequencies. So the WOW signal was about 1/4 as powerful as the radio output of our entire star, but concentrated into a tiny, laser-like frequency band instead of spread across a broad spectrum. That kind of focus is what made it so strange. Zoom out even further. The whole Milky Way galaxy, hundreds of billions of stars, gas clouds, and cosmic events combined, emits around 1 million Janskis of radio noise. The WOW signal alone was about 1/4000th of that, from a single point in space, for just 72 seconds. Now, compare it to human technology. A smartphone, if you held it a kilometer away from a radio telescope, could produce a signal of about 100 million Janskis. That dwarfs the WOW signal. But here's the key difference. Your phone's power vanishes almost instantly over cosmic distances. The WOW signal, however, traveled across interstellar space and still hit our instruments with 250 Janskis. That means its source had to be unimaginably powerful. Natural phenomena that produce radio bursts, like supernovas, pulsars, or black holes, usually spread their energy across many frequencies. They're like a roaring crowd where you can't pick out a single voice. The WOW signal wasn't like that. It was a single, sharp note, locked onto the hydrogen line. It was as though someone shouted into the quietest possible channel of the universe with astonishing clarity. And the most puzzling part, it happened once, then stopped. Whatever created that intense beam of energy shut off completely after 72 seconds. No repeats, no follow-up. Just enough to make sure we noticed. Then silence. The recalculated power didn't solve the mystery. It only deepened it. Whatever made the WOW signal wasn't just unusual. It was beyond anything scientists had ever seen before. Now comes the twist almost no one expected. For years, astronomers assumed the WOW signal sat neatly on the hydrogen line frequency, exactly where you'd expect it if someone, or something, was trying to send a message. But when researchers dug deeper into the recovered data, they noticed something tiny but critical. The frequency wasn't perfectly on target. It was shifted. At first glance, that might sound like a measurement error, the kind of thing old equipment could easily produce. But the more carefully scientists checked, the clearer it became. This wasn't a mistake. The shift was real, and it told an astonishing story. The signal was Doppler shifted. That's the same effect you hear when an ambulance races by. The siren's pitch sounds higher as it comes toward you and lower as it moves away. With radio waves, the principle is the same. If the frequency is higher than expected, the source is moving toward us. If it's lower, it's moving away. The WOW signal shift meant its source was racing toward our solar system. Not crawling, not drifting, flying. The calculated speed? About 84 kilometers per second. That's over 188,000 miles per hour. Fast enough to go from Earth to the Moon in a day and a half. To put this in perspective, most stars in our galaxy drift along at 20 to 50 kilometers per second relative to us. Even the fast movers rarely exceed 60. The WOW signal source was going nearly twice that. In astronomical terms, that's wild. What could travel so fast? Some objects are known to reach those kinds of velocities. High-velocity hydrogen clouds, for example, can be flung across the galaxy by supernova explosions or pulled around by gravitational encounters with massive stars. Some stars themselves, called hypervelocity stars, are kicked out of galactic centers after tangling with black holes. But here's the kicker. None of these are known to produce clean, narrowband signals at the hydrogen line. That combination, extreme power, laser-like precision, and blistering speed, made the WOW signal even more bizarre. Was it a natural object tearing across space under strange conditions? Was it a new kind of cosmic event we'd never seen before? Or, as some couldn't help but wonder, could it have been technology? Something designed and moving with intent? The Doppler shift revealed that whatever created the WOW signal wasn't standing still in the quiet backdrop of space. It was racing, cutting through the galaxy like a bullet. And for just over a minute in 1977, our telescope happened to catch its whisper. So here we are, nearly 50 years after a single 72-second burst changed the way we think about the universe. The WOW signal may never be explained with certainty. It could have been a natural hydrogen cloud flare, a magnetar lighting up space, just maybe something far stranger. What matters is how it reshaped the search for answers, forcing scientists to sharpen their tools and imaginations. The cosmos is vast, unpredictable, and still full of secrets waiting to be uncovered. If you want to keep exploring mysteries like this, make sure to subscribe. Our journey has only just begun.